So, we need to talk about home networking, and we need to talk about how people are using their home networks and what sorts of things you can do that you probably aren't doing today. And part of that is understanding the concept of network address translation and also something called VLANs. So that's what I want to discuss today. So this picture here is a little bit of an eye chart, but basically what it does is it tries to describe an average local area network, and then we embellish it greatly. So up here at the top, the cloud is the public internet. Then you have this box called a router. Everybody's got a router that they either bought retail or they purchased from their internet service provider, or their internet service provider provided it, I should say. And when you put it on your network, it gets a public address from the internet. Here is an example. I put in the fact that it might have acquired an address of something like 45.32.20.22. And then if we go straight down on this picture, I've got what I kind of consider the standard local area network that most people get from that retail router. By default, they usually choose a private address range of 192.168.1, and then the last number can be anything, and it has an 8-bit mask, which basically means 192.168.1.1 to 192.168.1.255. And in that range, there'll be a couple of reserved addresses, but that's not important for this discussion. So, and that's true of most routers that come out of the box. It's also true of a lot of devices you can buy. They're pre-set up for whatever reason to default to this 192.168.1.x network, which just is probably one of the most popular networks that you'll find. Now, on this side of the network, there is an address that I'm sure you've heard of that is called the router gateway address. And the router gateway address is simply the address of the router. And so off this line here, which represents that network, if we had a PC hanging off there, which I did not draw in this drawing, that PC could get to the internet by going through this particular router address, because it would find the router by going to the gateway address, and then it would go out to the internet. So the question is, how in the world, if this is a private address, let's say the PC is addressed at 192.168.1.10. How in the world does the communication go from 192.168.1.10 out over the public internet to something like google.com, and how does it get back to the user? So this green block here kind of describes that. When a client node on any LAN network communicates to the public internet, it encapsulates its private address, the thing we talked about, 192.168.1.10, for example, into the communication. The public WAN address on the router is also included in this communication. When you access a website, the website sends the response back to your public WAN address, and your router uses the encapsulated private address to know which system to deliver the communication to inside of your network. So that description of how that works is also referred to as network address translation, or NAT for short. And that's how today most retail routers operate with the IP version 4 protocol that you're used to, which is the dotted address with 4 numbers. For a totally different discussion, IPv6, which is a newer protocol, doesn't work that way and doesn't need to work that way, but that's probably the subject for a future video. In any event, I have drawn a picture here which is also kind of interesting, because in addition to having one plug off this router, you are seeing that there appear to be 3 others, or a total of 4 on the LAN side. And each of those goes to a different network with a different network address range. So a retail router that you would buy, something like this, maybe a Linksys or a D-Link or a Netgear router, is typically what we refer to as a multifunction device. It's multifunction because it contains a router and firewall function. It usually has some ports on the back of it, like maybe 4 ports, which is really an incorporated 4-port switch. So you could argue that, well, so there's the 4 ports being these 3 networks plus this network, but it doesn't really work that way. And one untagged VLAN, or one untagged LAN, I should say, and that's usually that 192.168.1. whatever. And sometimes it also even includes a modem. It kind of depends. If you have an AT&T device, it probably uses either DSL or VDSL, and so the device that communicates out to its network is incorporated within it. And some cable modem devices for companies like Xfinity or Spectrum may also include an integrated modem into them. So basically, it's a multifunction device that does all those things. Oh yeah, in addition to that wireless access point, you can see the 2 antennas here. That it's the thing that gives you your Wi-Fi as well. So this private address space, there was a standard that was established for private address spaces. That means inside your network, the things that NAT, network address translation, operates upon. There's 3 private address ranges. One is 10.0.0.0/8, which means it's an 8-bit address. So it goes all the way from 10.0.0.0 to 10.255.255.255. So, and then there's another lesser known address space. Oh, the 10 address space, by the way, is the newest one they added to the private address space. A lesser known one is 172.16.0.0 with a subnet mask of 12. So it goes from 172.16.0.0 to 172.31.255.255. And the one that everybody here is familiar with is the one that is at 192.168. And although you see .1, it's actually .0.0 with a 16-bit address, which means that it can really be any network between 192.168.0.0 all the way to 192.168.255.255. It's just that when your router is set up, it's normally given the address space for your private network as being 192.168.1.0 with a subnet mask of 24, which effectively means your address is run from 192.168.1.1 to 192.168.1.255. So this is a picture here in reality of more of a commercial router, where it does have 4 ports here, but each of the ports is designed to go out to an independent network. And the retail router, yeah, it may have 4 ports on the back, but all those ports hear everything all the other ports do. And that ports not, those ports are not, from a software perspective or from a hardware perspective, set up to do routing. And so consequently, they all hear everything the other port hears. Now, I'm going to challenge you to think about using something like a managed router. And the reason to use a managed router is because it gives you the ability to have more capability, which we're going to talk about. Yes, it again is routing and a firewall. It again has switch ports on it, but it adds to it the concept typically of deep packet inspection, which is a way to examine the data coming over the router and determine or act upon that data in one way or another. And then also it has the ability to deal with these things called virtual LANs, or otherwise known as tagged virtual LANs. And then they also typically do geofence and other things like complex router rules that say what kind of traffic can go over the network or between the networks. So what I've got here is I've got a picture that is depicted with what it looks like are 4 networks. But I want to tell you that the other capability is that VLANs really, they're virtual. You can't touch them or see them, but they're different. So in my picture, I have a 192.168.10.0/24. So there's a 10 network, which means that everything on here goes from 192.168.10.1 to 192.168.10.255. And I've got a PC, a laptop, and a tablet on that network. You might consider that to be like maybe the user network. And you might look at this one up here to be an independent other user network, if you will. And then down here, I've got a network which I kind of consider an Internet of Things network, a place to replace untrusted devices that we really didn't write the software for and we don't know what they're doing. And so we want them isolated from our regular traffic. And we put them on 192.168.30.0. And we have things like an Amazon Echo, a Google Home, and maybe a Nest thermostat. Those are some good examples. And then we might have another address range, which might be 192.168.50.0 with a 24-bit address range. And it may contain some cameras. So why would we want to put cameras on a separate network? Well, that's where we get into what we actually do with these VLANs. And that's kind of the subject of this tutorial. So, advantages of VLANs. So VLANs, again, are virtual LANs. And although we depicted them as separate wires or cables or interfaces coming off of the router, in reality what they are is they're multiple networks that are physically on the same wire. But they're divided by the fact that the routing rules can deal with virtual LANs. So you have an ability to divide traffic. And why would you want to divide traffic? Well, there's 2 predominant reasons to divide traffic. One is security and the other is performance. And a really good example here was what I had on the previous page, where I had an IoT VLAN, Internet of Things, for your common devices like your smart speakers, maybe your set-top boxes, your Rokus, your Fire TVs, that sort of thing. And then maybe another VLAN for cameras. And the reason you want to put the cameras maybe perhaps on another VLAN is maybe for traffic reasons, because you have these wired cameras and you have a lot of them and they produce a lot of traffic. So you can divide that traffic and not have other nodes compete with that traffic because maybe they don't need to. That and the fact that a lot of camera firmware nowadays might be produced in China, and you really don't know if it's phoning home or whatever else it's doing. You probably don't want those cameras on your primary network. So the other thing is the ability to communicate to multiple networks over a single Ethernet adapter on the same wire. We already talked about that, but you can't restate that in enough ways because that's really the main reason to do this. So managed switches. So we managed routers are routers that can handle this sort of capability, and managed switches work along with managed routers to allow port profiles for one or more VLANs. So this gets kind of interesting here. Layer 3 switches even manage data traffic on the switch instead of having to rely on the router. So on a typical retail router, if you have a 8-port switch hanging off of it and you have 2 PCs and PC A tries to talk to PC B, what it's going to do is PC A is going to talk to the router, and then the router is going to tell it where to find PC B, and it's going to go down onto the switch again to find it. On a layer 3 switch, it can actually optionally do routing on the switch where it sends the data directly from PC A to PC B and doesn't involve the router. And there are some logistical reasons to do that above and beyond the obvious of just giving a more direct route. So what are the disadvantages of an unmanaged router network? That is the device that you might have gotten from your internet service provider, or the device you might have bought retail, even if it is, quote, maybe a gaming router, if it doesn't provide these capabilities that we get from a managed network. Well, so typically routers that control unmanaged networks are limited to managing one private IP address range, like the 192.168.1.0 that we talked about in the diagram. And then all devices on the network can talk to each other, and security must be tight at the client level if there are any untrusted devices on the network. So in the industry, we talk about the fact that that's a network that's hard on the inside and maybe GUI on the outside, which means that all the security pretty much occurs at the node level. The other aspect to that is the fact that we always refer to routers as firewalls. And that word firewalls used really loosely. I mean, I could probably build another video just on security, but just understand that the reason it's called a firewall is because of the fact that nobody on the internet can initiate communication arbitrarily and talk to a private node on your network unless there's an opening in that firewall, or unless the thing on the network initiated the communication and the thing out on the internet is responding. But that being said, I'm sure you all have heard of Trojan horses, and a Trojan horse is basically a piece of software that initiates communication on your network to maybe an unknown node out on the internet, which then opens a channel for them to talk to something locally on your network that you didn't intend to happen. So that's where we have to sometimes look at the traffic that's going on. Typical retail firewalls are only really hardened from the outside in and not from the inside out. And you have to look at that inside out capability as well. So unmanaged routers are usually multifunctional, and the router firewall it's also a router firewall, it's a switch, it's a wireless access point, and even modem, and they're all inside the same network. So one of the things, or inside the same device, I should say. So one of the things that you want to do is you want to split these things up from the point of view of being able to upgrade components one at a time. And the other thing that you want to be able to do is you want to concern yourself with the fact that when newer technology comes out, you want to adapt to it. A good example is you may have bought that really great gaming router and spent a bunch of money on it. But what happens when they now come out with the new Wi-Fi 6 or Wi-Fi 6 Plus, which is barely out, and now you want to have that newer, faster Wi-Fi, you have to replace the entire router. Whereas if your wireless access point were a separate device, you could go out and just replace that component. So normally these multifunction devices are retail devices, and they don't really receive regular security patches and upgrades. And that's important. You buy the new device and it works really fantastically when you get it. And then here it is 6 months down the road, they get a great software update. You're thinking, cool, they're keeping me all up to date and everything. A year down the road, you get an update. And then 18 months down the road, you quit seeing any updates at all. Before you know it, the device is 5 years old and doesn't patch for any of the vulnerabilities that now exist out on the internet that are known. So that's one of the reasons why you want to look at a device that's a more serious device. And so most of the managed router type devices receive regular software and firmware updates that handle these sorts of things. They don't ever become stale like, say, a cell phone does after you own it for 24 months. So these VLANs, how do you use one? Well, I use Ubiquiti Unify switches. Ubiquiti is an interesting vendor, and there's kind of a mix of belief out on the internet in regards to the way that they operate. I could really dive deeply, but there's a lot of really terrific videos online already about Ubiquiti Unified devices. So I'm just saying that that's what I use here. I'm fairly pleased with it. I think their switches and access points are at this point more mature than their routers, but there's nothing wrong with their routers unless you have a complicated use case. So I always consider a best practice is to create VLANs of the following type of form. So if you have a network you want to address, a VLAN, virtual LAN, you want to address at 192.168.30. Whatever, so it's a 24-bit mask. So I create that network and I call that VLAN 30. I call it 30 because it's using the number 30 here. You don't have to do that, but it's just kind of a way to let that VLAN self-document itself. So first, in order to do this, you've got to have a router capable of managing VLANs and a switch that's a managed switch. Because if you don't have that, you're not going to be able to do that. And likewise, your access points also must be managed access points if you want to be able to provide wireless services that use VLANs. Although you could use an unmanaged access point and connect it to a managed switch and set that managed switch to a particular VLAN, and that would work too, but it's not the best use case. So usually the switch port that a computer is connected to either uses the untagged VLAN, sometimes people call that VLAN 1 on the network, or the port profile of the port is defined to be a particular VLAN. So in the UniFi world, that looks a little bit like this. I'm looking at one particular port. This is the port for something I call front yard camera, and it's connected to my VLAN 30. And my VLAN 30 is a network that I use for IoT or camera type devices. I didn't divide cameras and IoT in my network. I just consider them all IoT. But this port profile by default on a managed switch would normally be all. So if you had 10 VLANs, it would give you access to all the VLANs. But if you connect a device to that port, it would normally connect to whatever that default LAN is, that VLAN 1, which is like the first LAN on your network before you create any VLANs. So even if you had 10 others, it wouldn't connect. So you can create a port profile that has all the VLANs, 2 or 3 of the VLANs, 1 VLAN, whatever. It's very, very flexible. And you'll see why in a moment why you might want to have a port profile that has more than 1 VLAN on it. From a security point of view, though, you might want to limit a port to a particular VLAN, because let's say that somebody gets a hold of your camera on the outside of your house, disconnects it, and plugs something into that cable on the outside of the house. If it is specifically on that IoT VLAN, you have router rules which won't allow them to get back to your main network. So that in itself is built-in security and one of the beauties of a VLAN. So my VLANs are all configured router rule point of view from the fact that the main VLAN can talk to any other VLANs and receive a response from it. But the other VLANs are not allowed to initiate communication back to the main VLAN. And that's a pretty typical use case. So how to create a VLAN adapter? Well, you can, once you have a VLAN out on a managed network, if you have a port number that's wired to that particular VLAN, like we just showed you on the previous page, you just simply plug your Ethernet cable for your PC into it and you're on that VLAN. But what if you don't want to do that? What if you left the profile at all, but you want your computer to connect to multiple different VLANs? So I've given the answer here, or I'm looking at the answer in the typical Linux Ubuntu. I'll address Windows here in a little bit too. But in Ubuntu, we need VLAN support for what's called 802.11q, which is the VLAN specification. In order to get that, we have to install VLAN support, which we install, we do a sudo apt install VLAN, and then we do a sudo modprobe 802.1q, and that goes ahead and allows us to create VLANs on the network. Once we do that, we can create a VLAN interface. So assuming this VLAN 30 that I talked about previously exists because it was established and created on the router, but assuming that maybe my profile that my PC is connected to is all. My standard Ethernet controller is connected to VLAN 1, but suppose I also wanted to connect to VLAN 30. Well, I can sit there and say sudo vconfig add eth0.30. So what that does is it goes ahead and, assuming my Ethernet device was something like eth0, I mean, you're going to do like an if config and see what your Ethernet device is named. This would create a second Ethernet device called eth0.30, and it would get another IP address and all that cool kind of stuff. So port profiles with multiple LANs. We already said the switch can be configured to manage multiple LANs. So suppose your port profile is all and you've got like 10 VLANs out there defined on your router. Well, to communicate with another VLAN, you can simply create a VLAN adapter that shares your physical Ethernet interface, because that's the whole point. You can have one cable connected to one Ethernet adapter on your one PC, and it can actually connect to these multiple virtual LANs. That's where the beauty comes across. It's like having two Ethernet adapters in your computer. So for example, if your Ethernet adapter is called ENP4S0 like mine is, it's an Intel adapter, you can create an interface called ENP4S0.30, assuming VLAN 30 is defined on your network. Okay, so here I do like a sudo IP link add link ENP4S0, and I add this thing and then I show it. So there's the adapter. Okay. So all this command line stuff is great, but there's an easier way. There always is an easier way. Some people are going to be critical because, after all, we should all in the Linux world understand how to use the CLI, the command line interface, but there's a GUI way to do this too, and I kind of like it because it's quick and simple. And simple and quick always counts. So assuming you've installed VLAN support, what does that mean? Well, it means that you've installed VLAN as we said on the previous slide. You're going to install and start the Network Manager service. So that's in addition to the VLAN support we talked about in the other slide. So you're going to do a sudo apt install network-manager if it's not already installed. And Network Manager is another layer interface that lets you get a lot more granularity of control on your network. And then you're going to make sure Network Manager is started. You do a sudo systemctl start network manager.service, and you might want to also do a systemctl enable network manager.service, which will make sure that it starts upon the next reboot of your computer. And then we're going to start the connection editor. So you go to a command line prompt and you do an nm-connection-editor, or you can set yourself a shortcut to do that so you can fire that up easily. So this is what the network connection editor looks like. And in my particular case, you can see I have a Bluetooth connection to a phone. I have a wired connection, which is my main wired connection. It's only connection 2 because I've deleted and recreated my wired connection at least once, and I never renamed it. I got a bunch of Wi-Fi connections down here, and this thing actually scrolls down the screen, but this is what the main screen looks like when you fire up the connection editor. So if we want to add a VLAN adapter, we click the plus sign at the bottom of that previous screen that we just saw. And when we do that, it'll say choose a connection type. And it has a drop-down menu. And the drop-down menu by default will say you want to create another Ethernet adapter. Well, if you have other physical Ethernet adapters in your machine, have at it. You can do that. So you're going to scroll down in that drop-down list and you're going to choose VLAN because I want to choose a VLAN adapter. And then I want to create the new VLAN adapter. So you click create and you're going to fill in the fields. And for example, on my network, I have a VLAN called LabNet, which is a test network where I do dangerous things. And it's called VLAN 50. And so it uses the address range 192.168.50. Whatever, okay? So you choose the parent interface as being your physical Ethernet interface. This is also a drop-down menu in this GUI, in my case ENP4S0. And it says it's going to use that via wired connection too. That's how it's working. And it says which VLAN number. I say 50, and it knows how to talk to VLAN 50 on the cable. And it says, what do you want to call it? And I'll call it LabNet. I mean, I could call it something like ENP4S0.50, but instead I decided to be really user-friendly and just call it LabNet. And then leave everything else the same. So the resulting VLAN kind of looks like this. After you click Save, the connection relies on the fact that the switch profile on your PC is connected to and includes VLAN 50. So if that switch profile is set up to either be all, or that switch profile has VLAN 50, VLAN 40, and say the untagged VLAN, which it would by default, then life will be fine. So here it is. It shows up under the VLAN area, and it says LabNet VLAN. And it says you just created it. Last time you used it is now. So here's what the new adapter looks like. You go into a terminal, you do an if config, and you should see the new LabNet connection and the IP address. So you see here in this case, it looks like it's its own separate physical Ethernet device. You can't differentiate it from the regular wired device, but yet it got an address from the DHCP server that's on my VLAN 50. So therefore it got the address 192.168.50.131. And so that's pretty neat. So now if I had an app, I'm now connected to my default LAN, which in my case happens to be 172.16.x.y. And I'm also connected to the 192.168.50.131. So I could actually write programs that could talk to either interface or talk across interfaces. And that's some functionality that I've got, which is absolutely fantastic. So tag VLAN connection. So when we have a number, like VLAN 50, that's called a tag. The tag is 50. And so how do we do this in Windows? Well, VLAN tagging requires that the network interface card, the NIC, that's in your PC, and the router or switch that you use supports IEEE 802.1q. This is true in Linux and Windows, but I'm just restating it because that's the specification for VLAN routing. And depending upon the network interface adapter you have, you can set up your VLAN in Device Manager for Windows. Not all NICs that support VLAN tagging have that option, but most of them do, especially modern ones. So you want to log into Windows as the local administrator. To open network or to open Device Manager, you want to go ahead and hit the Windows key plus an R, which will open the run prompt. And in the run prompt, you want to type dev mgmt.msc and click OK. And that'll go ahead and add the add-in for the Device Manager and bring up the Device Manager on your screen. So how to create your tagged entry. In Device Manager, you're going to look for network adapters. And you're going to right-click on the network adapter, the NIC that you use to connect to your network right now. And you're going to click the Advanced tab. You can scroll down to VLAN ID, and you can set the VLAN ID that you'd like the NIC to have and click OK. And voila, you should get an address on that particular virtual LAN like I did in the Linux world. So to wrap this up, VLANs are a powerful means to manage your traffic and to improve security. It does a little bit of both because it depends on how you implement it. But you can actually come up with a network architecture. The reason you can come up with a network architecture is because suddenly all your traffic isn't on the same network. It can be on these multiple virtual LANs. The router and switch must be managed devices capable of VLAN routing. So hey, I hate to say this, but those retail routers and the devices that the internet service providers provide you for routers, they're not going to be managed devices. And virtual adapters on a computer that we established, and we did it in Linux and we did it in Windows there, can communicate with more than one VLAN through a single VLAN adapter, or a single LAN adapter, I should have said. So that's the beauty of it. You can have more than one network on the same cable, and we said that up front as we started to describe this. So anyway, that's about it for today. I hope this helps some people out, and I hope you'll subscribe and like, and we'll see you on down the road when we decide to do the next one. Thank you so much for listening.